Hi, everyone. I'm meteorologist Royal Norman, and welcome to Sonoran Sky, a podcast presented by First Alert, Arizona's family First Alert, and we cover everything, the gambit here. And today we're going to talk a little bit about climatology and but the latest bit of information we heard as we're going into the winter months of La Nina. And Shel Winkley is joining us from the Climate Central. Shel, how you doing today?
Oh, we're good. We're waiting for some fall-like temperatures, but we're doing good. We're doing okay.
Shel, first of all, I like you guys to always sort of set the table. What is Climate Central? What's your main mission? What's the goal of what you do?
Yeah, so we are a non-advocacy nonprofit that deals with the science and the data of weather and climate change, right? We try to put it all together and help everybody understand just the trends that we see. We can do some science, like attribution science, where we can really put a fingerprint of climate change on your daily weather, on an extreme weather event. And then we communicate it and we help others communicate it as well, because same as like a weather forecast, right? What good is all these datas and the science that we've gotten so good at? We really understand better and better every single day if we can't talk about it and really apply it to our everyday lives. So that's what Climate Central does in a nutshell.
Yeah, it's pretty cool organization. They produce a ton of graphics that not only our TV stations use, but TV stations use all around the country. And I think one of the reasons for that, one of the great things that you guys do is just sort of you simplify it. You don't try to say 10 things on one graphic. You make it simple. Here's what I want to tell you on this one graphic. Boom, and you guys get it done.
Yeah, we make it clear. We make it local, because that's the big thing too, right? We can talk about climate change every day, all around the world, but it matters what's happening in your backyard to you and your family. So over 240 cities are what we analyze across the United States. And again, we can use that attribution science globally and really understand it.
So, Shel, I'm floating my way through the end of summer into fall, thinking, we're going to do a little ENSO neutral and maybe roll into maybe a little El Nino. I hadn't checked in a while. And all of a sudden, time out on the field. We're doing La Nina again. First of all, was that kind of a surprise that we're now forecasting pretty likely La Nina over the next several months?
Yeah, it's interesting. We just came off this big El Nino. We went to an ENSO neutral pattern. We've had this hurricane season that, knock on wood, has really been just quiet. I don't want to say that too loudly though, right? Looking at really global temperatures for ocean heat, the past couple of years, we've been at record levels. And this year's right now, I was looking today, we're running at about the third or fourth warmest in terms of the amount of heat that the ocean is carrying. And not to say that you can't have some cooler areas like with the La Nina that we're watching there in the equatorial Pacific, but that is a very small portion of the ocean compared to how much heat is happening elsewhere.
So I have no idea, because I don't study El Nino, La Nina, ENSO neutral. But it seems like from when I was a kid studying this stuff, first of all, you only heard about El Nino and then it would last like 7 years. It seems like this stuff is bouncing around a lot more than it used to. Is that just me misunderstanding what's happening, or the science getting better detecting it?
Yeah, so both, right? First of all, yeah, El Nino, La Nina, that's still in the grand scheme of weather and weather forecasting. It's relatively new. I think the American public got to understand it when Chris Farley got on SNL. I was like, I am, El Nino, right? That was one of the greatest skits that SNL did. We've gotten better at it. Our satellites have gotten better at being able to measure the temperatures there at the equatorial Pacific. But one thing that's really interesting is, there was a pretty solid standard. We have NOAA here in the United States. Each country has their own meteorological organization. And other meteorological organizations across the globe are now starting to say, okay, so we understand El Nino, La Nina better, but we also understand that climate change is warming the oceans. And that we now have to bring that in, because La Nina is cooler waters at the equatorial Pacific. El Nino is warmer waters at the equatorial Pacific. But if those temperatures are abnormally warm, and we understand that water is made warmer to a certain degree because of climate change, then we have to factor that in so we understand, is an El Nino actually happening? Is a La Nina actually happening? Or is this just a byproduct of climate change that we're seeing these temperatures?
Oh, wow. So the whole thing may be just changing in front of our eyes. That's just crazy.
Yeah.
Tell me about this La Nina that we have coming up. Typically, and I'll give you the sort of cliff notes, if you will, for Arizona and winters with La Nina. Typically, they're drier and they're hotter. But that being said, about 1/3 of them are wetter and hotter than normal, or warmer than normal, if you want to say that. So it seems like there's a 1 in 3 chance that we could be wetter than normal, but there's a 2 in 3 chance we could be drier than normal. And you also look at some of the other playouts of La Nina, a fair amount of rain and snow for the Pacific Northwest, maybe even Northern California and in the Ohio River Valley. So how do these little, I'm going to call them eddies, play out over long term, and we're able to sort of put a finger on them?
Yeah. So one thing I love about weather is that everything is connected, right? What happens on it, that old butterfly effect, right? What happens on one side of the world can impact you. So those water temperatures at the equatorial Pacific are important because they really fluctuate the jet stream, particularly in the winter. So we are currently under a La Nina watch, meaning that the signs are there that the water temperatures are abnormally cool.
Mm-hmm.
And that's why NOAA believes that we're going into this La Nina. So, and it should be a short-lived one, is what they're saying. So it shouldn't last long. But yeah, so what it does, those cooler waters of the equatorial Pacific keeps the jet stream generally further north. So the storm track, the way we move weather across the country, is cruising across the northern US instead of dipping down into the desert Southwest and into the South. So that's why usually La Nina brings warmer, more mild weather to the winter, as well as drier, because you're not getting the big dips in from Canada. You're not getting these big rainmakers or snowmakers linking up with some of that cold air. But like seasonal outlooks, that doesn't mean that there's not cold weather to be had. There's not going to be rain to be had, right? It just means that the overall trend of the upcoming winter is likely to be warmer and likely to be drier. And the Climate Prediction Center has put that out in their winter outlook as well.
Shel, I was talking to a fella from SRP, which is one of the local utilities that is in charge of a lot of our water in Arizona, the Salt River Project, and we were talking about the same thing. And I asked him, okay, so what does this mean? And he goes, well, you want the bad news or the good news first? I go, okay, give me the bad news. And he basically said what we're talking about, that overall the trend would be most likely drier and warmer winter for Arizona. And he played it out how they would plan that and plan for that, because they have to plan for snowpack, et cetera. And I said, so what's the good news? He goes, well, the models haven't gotten any better in 20 years, so who knows what's going to happen. Do you agree with that? I mean, he seemed to think that the models were almost still a flip of the coin, if you will.
No, not at all. And I think, not to disagree with them completely, but yes, like, are there still some deficiencies in weather forecasting and getting into that real nitty gritty of each individual storm? Yeah, because, right, it's a chaotic atmosphere. The models have gotten so much better. And one of the reasons they have is because, one, again, we have better instruments to put data into those weather models. So as long as we can keep doing that, then the models have something, it's the same as good input in, good input out, right? If you
Right.
have an error at the beginning, you're going to have an error at the end. But two, just computing power, right? Like, even,
Yeah.
I was started being a meteorologist in 2007 when I really started paying attention. And yeah, like a 3-day forecast was good, and that was about it. Now, 10-day forecast, 2-week outlooks, you can glean something from it. So, like, when it comes to the climate models, especially, or those long range models, we have gotten exponentially better at forecasting.
So
Doesn't mean it hits every single time. No, but we have gotten better. But there is that unnatural thing to bring it back, and that is climate change, right? Like, we have
right.
changed things and made it a natural weather pattern slightly more unnatural at times. And the forecast models are still sometime, at least in the short term, trying to figure out what's happening there.
Now, another thing you folks just in the last couple of weeks have been talking about a lot, and I think this, if I looked at the maps correctly, I didn't look in depth, so I apologize, but first of all, it's the lengthening of the fall season. It stays warmer longer. And it seemed like a lot of that impact was, say, east of the Mississippi or maybe the middle of the country eastward. But is that kind of a phenomenon that's happening everywhere where fall is just getting warmer and lasting longer?
Yeah, so we recently just did an analysis of fall temperature trends, looking back just 50 to 55 years. And we go back to 1970 because we really understand that that's when climate change's impacts really started building was 1970. You could really start to pick out the fingerprints there. But also, we the weather world really built everything off of 30-year averages. So it's a 30-year average plus some. So we're really encompassing it all. The point of this is that looking back to 1970, every single county in the lower 48 has experienced some sort of warming in the season of fall. And we're talking September, October, November specifically, meteorological fall, compared to just 50 to 55 years ago. Now, the good news for Arizona, are you ready for it?
Yes.
Some good news. I'll give you some good,
All
bad
right.
news. All right, so we'll start with the good news. Fall is actually, of the four seasons, the slowest warming season in Phoenix, as well as pretty much every city that we've analyzed,
Oh,
in Arizona. So at least your fall is kind of like a fall. I think about it like the seasons of past that our parents and our grandparents got to
yeah.
experience.
Yeah.
The warming is not as strong in fall as it is, say, in summertime,
Yep.
especially springtime. And then it goes to, yeah, fall or winter, and then fall is the lowest. So you've seen a lot of warming in other parts of the year, but your fall season is better, at least,
I
than what you've
like
experienced.
that. Yeah.
Not to say it's good, but at least better than the other seasons. Now, to say that and to give you an idea, your fall there in Phoenix since 1970, the average temperature has warmed 5.7 degrees Fahrenheit.
Yeah.
So that may not sound like a lot over 50 years, but think about if your body temperature raises almost 6 degrees, you're in the hospital,
Yeah.
right? So
Yeah.
like even though fall is of the lowest of the seasons in terms of warming, that's significant. And what that means for you is that you're now walking out the door uh, to an addition of 38 extra days of above average temperatures. So back in 1970, you expected, because fall is that time when like summer's still raging and trying to go, winter is trying to claw its way in, right?
Yeah.
You used to experience on average, fall has variability, 25 above average days back in 1970. Now, on average, you're experiencing about 60 above average days between September, October, and November. So that means that 66% of your fall is now generally expected to be above average there in the city of Phoenix. So when we talk about fall feeling like what our grandparents experienced, it's not the same. It's just not the same. Your pumpkin spice lattes are iced pretty much all of the fall season.
Okay, so now a lot of folks are going to say, because I hear this too, is that, okay, well, wait a minute. A lot of this is because of urbanization, all the buildings we've built. But the bottom line, correct me if I'm wrong, you can look at these statistics at even our smaller cities around town, around the state that don't have a lot of urbanization, and it still holds true. We're still seeing these patterns.
Right. Because remember, every single county across the lower 48 has experienced some sort of warming. And it's important to know that's not a wrong take, right? We do understand that we've added more buildings, we've added more concrete, we put more people, more cars, all of that emits heat. So essentially what we've done is we've burned coal, oil, and methane gas. We've put heat trapping pollution to the atmosphere. That has put the flannel shirt around the earth that's holding in the temperatures. But yeah, the other part of that is urban heat island effect. But remember, that is still a human caused warming thing.
Right.
We as humans have transplanted out the natural vegetation and we've put in things that emit heat. So that's still something that we have done as a society, is added this heat to the city.
Okay, so I'm going to tell you a little story, and then I'm going to ask about the big Pacific blob. But first of all, this has to do with fall, so I'm staying on course here, Shel, so you can understand that. But back in 1984, when I first started doing this, oh my gosh, we used to say, well, I didn't used to say, but I picked it up from the other meteorologists in town that worked at the Weather Service and at the TV stations. We used to say, when does it finally cool down in Arizona, as we would come out of the summer? And not necessarily when would you not get another 100, but just when does it cool down? And we used to always say the first week in October. And then a little bit later, 10, 15 years later, we were saying the second week in October. And now when people ask when's it going to cool down, we just say Halloween. Forget about it. It's true.
But even then,
Yeah.
it could still be warm, right?
Yes.
Like we experienced, I'm in Texas. We experienced the same thing. I love October. I love Halloween. I will tell you more often than not, we've had sweaty Halloweens, and I think in recent history, in at least since 2020, I can remember one cold Halloween that we've had. And not to say it needs to be like bone chilling cold to
Yeah.
go along with bone chilling holiday, but yeah, it's not the same. And in fact, we have done a recent analysis on that as well. And so for Phoenix, we looked at 75th percentile temperatures. So like a standard summertime heat temperature, which for Phoenix would be 100 degrees. On average, it's now 8 days later than it was back in
Ah.
1970. So it used to be, yes, October 1st was generally about the time that you would experience the end of the 100-degree heat regularly. Now, on average, it's more like October 8th. Doesn't seem like a lot, but we know that that shifts from season to season. And when we get going back to La Nina, you get into a La Nina pattern where you expect above average temperatures a little more often. That's going to drag it out a little longer as well. So, yeah, you might be dealing with that kind of heat at Halloween.
All right, one more sidebar, Royal says, and promises one more sidebar. So we've been getting a lot of emails into the weather department saying, you should be reminding folks that we had such a cool summer. We had a fantastically cool summer. And we did feel like we had a fantastically cool summer. It was way down from the past couple of summers, way down from last year's record summer. Like overall, I want to say 2 or 2.5, maybe 3 degrees. But guess what? It's because what you get used to, it was still the fourth hottest summer on record for Phoenix. And folks were going, oh, we've never had a summer like this. Well, yeah, you have. This is the fourth hottest, and we didn't even realize it because it was so much cooler than the year before. Isn't that crazy?
Right. And not to discredit that, right? Because that's something to
Yes,
celebrate
something.
that you're
Yeah,
not a
no,
record
yeah,
summer. Yes.
yeah.
But that's the thing. And again, experiencing the same thing here in Texas, where we had these just blockbuster summers of heat and drought. And then we had this year where like we had some timely rains and temperatures seemed a little more typical,
Yeah.
but yeah, it was still one of the hottest summers of record, but in your near term recollection, yeah, it doesn't feel as bad as the past couple of summers you just lived through. And one of the reasons why, and I haven't dove specifically into the data for your summer, but I guarantee if we look at it, it's probably there. Nighttime
Yeah.
temperatures leap through what is happening to be the warmest part of summer, which is your overnight lows.
Yeah.
That across the country, we know are warming about 2 times faster than daytime heat is during the summer months. And so we're sleeping through it. We get the air conditioner still running, and we're not really recognizing that our night times are significantly warmer across a good portion of this country. And one of the side products of that is think about, if you were paying attention, all the flooding events that occurred over the summer, Texas,
Mm-hmm.
North Carolina, the Northeast, Chicago, right? There are just so many. This is the summer of flooding. One of the reasons is because we carried so much extra humidity, extra moisture in our atmosphere to feed these weather systems. And what that also does, that added moisture that we have in our atmosphere because of warmer oceans, means that those overnight lows can't cool quite as, or really just like they used to. And that's one of the big reasons why your summer was one of the hottest that you experienced. Just maybe you didn't experience it because you were sleeping through one of the big blinking red lights of the summer. Yeah.
Yeah, I think you're absolutely right about that because, and I haven't done the numbers on it, but we had a lot less days where we didn't stay above 90 than the summer before when we set the record. So that is definitely part of it. All right, I'm going to talk about the heat blob in where is it? In the northern Pacific, somewhere up around Alaska, or is it further south than that, where we've got this tremendously weird, bizarrely area of heated ocean that's doing what? Surprising us? Why are we worried about it?
Yeah. Okay. So you're generally looking, if you're good with maps and you like latitude and longitude, like your standard normal human, 25 north to 60 north is what we're looking at. So essentially, you're thinking about the coast of Japan,
Okay.
the east coast of Japan, all the way to the coast of Oregon, Washington, as well as Northern California.
Okay.
That's a big, big basin
Big
to look at,
chunk.
right?
Yeah.
Yes, we know using that attribution science, those fingerprints of climate change that we talked about, we have a scale, we have a product called the Climate Shift Index, so we can understand it on a daily basis. That scale goes from 0 to 1,000, to put it in perspective. We know that the water temperatures in this marine heat wave that's at record levels of heat in this portion of the ocean is anywhere from 50 to 400 times more likely to be this warm, at least in mid-September, than it would be in a world without climate change. So we've added this extra heat. So going back to El Nino, La Nina, right? So we just went through this El Nino. We had a lot of heat in the Pacific, equatorial Pacific, and we have oscillations. That's how things change, right? That's how the oceans that have always done this try to balance the heat and the carbon that is in our atmosphere. That's the role of the ocean. The oceans are important. And if you don't think about them daily, maybe you should, because it literally drives a lot of what we have. We are a water planet. That being said, part of this is that change. As we go into La Nina, we're starting to see a redistribution of the warmth. But we also know that temperatures like this are almost virtually impossible without climate change. And every time we redistribute this warmth with the added warmth from climate change itself, we're just essentially raising the baseline, right? So you're thinking like, oh, maybe the ocean temperatures aren't quite as warm as they were last summer. Well, they're still at record levels. They're just not quite where we were because, again, we're raising that baseline. So as of right now, this big area in the North Pacific is running on average about 3 degrees warmer than it should be. But remember, this is a large area. Some pockets of ocean warmth are as much as 5 or 7 degrees above average. Why do we care, right?
Yeah.
That's the You're in the desert Northwest. I'm in Texas. Someone's on the East Coast, maybe watching this because a family member sent it to them. We care because of a couple of things. One, ecosystems, the fish and the whales and everything that's swimming around in there. Some of those marine life have the ability to move further north, go find cooler waters that they're used to. But maybe their food source can't go with them. So while they can move, now they're looking for something to eat and it's not there.
Mm.
The other big thing that maybe, so you don't care about what's happening in the water, but maybe you care what's happening at your home. A lot of our weather systems, especially when we get into the fall and the winter, start their genesis south of Alaska, coming off of Russia, right? So now we can make bigger storms, bigger windstorms, bigger significant extreme weather because these ocean temperatures are warmer. And again, the jet stream is up there and there's an interaction between the ocean and those upper air currents that could really throw off what is a typical winter pattern for us, especially when you throw in La Nina on top of it, that's already kind of messing with those normal winter patterns. So that could mean less snow. Or let's say you do get a snowstorm, you beat the odds, you beat El La Nina, you beat what climate change has done in terms of snowfall trends in Nevada and California. But then you get this really big storm that's a really big, impactful snowstorm because we know the storm system is stronger because of ocean temperatures. We know that with climate change, the atmosphere holds more moisture. So if we can link it up with cold air, then we have this bigger snowstorm that could cause impacts to you just trying to live your best life on a daily basis, right? That can really cripple cities. So again, it takes what are normal weather patterns and it turns them just a little more unnatural, and it changes the game a little bit in that regard.
So that's why it's important. And so, like when the whales and the other fish and whatever are trying to figure out how to live in the water, we may have to try to figure out how to avoid maybe some more severe storms out of the water, as we have seen in some places. Is there any way to turn that back, or is that just a done deal at this point?
I mean, sure, you're going to eventually probably see some upwelling and you can get, it's really hard. That's why when we talk about this attribution science, we can go from a scale from 0 to 1,000 because it's really hard to change ocean temperatures quickly, right? You get a cold front on land and things flip within 30 minutes to an
Yeah.
hour. The only way you do that with an ocean is a really big storm system, a really big hurricane in the Atlantic, right? It takes something to really disrupt what's happening with that warming on the sea surface. So again, it doesn't mean that we're going to stay at this level of warmth in the North Pacific, but again, it also means that this baseline of what is normal continues to inch upward. And it just means that we're just holding on to more and more heat in the ocean, which eventually can impact ocean currents, which again help to move weather around the world. So it's not just what is in the water, that's important too, but it is happening of how we how we experience weather. It comes from the oceans.
That's cool. Shel Winkley, I appreciate your time. We've had you on before. Promise me this, middle of winter sometime, we'll do an update and see how things are going with La Nina, if it's flipped over to El Nino, and just see who's getting crushed with the snow. And who knows, we're going to keep our fingers crossed in Arizona that we get some decent snowpack, because we need some snowpack not only in Arizona, but in the Colorado River Basin. As you know, we need some snowpack down here, and we need it bad.
Snow is fun for snowmen, but yeah, you nailed it. Wintertime snow is so important to our water source, especially as we get into those warmer months. So yeah, I'm happy to come back, and let's check it out in a couple months.
All right, take care of yourself. Have a good one.